Hello everybody, welcome to the VirtualCube 2.0 intro video. The students that have been working on this VirtualCube 2.0 project is Kenneth Kahn and Michael Lazo, and the mentor that's looking over the project is Bernard Pintu. To give a quick overview on the VirtualCube 2.0 project, what this project aims to do is to get rid of those physical lines, the physical long, boring line to get onto a ride in the theme park. And in order to complete that project, the roles that the students had on this project was, for me, Kenneth Kahn, was a developer, alternating Scrum Master with Michael Lazo, testing, and document editor. And Michael Lazo also had those roles as well. So the problem definition for the VirtualCube is the VirtualCube is a online alternative to standard waiting lines that currently exist in the theme parks today. But the current limitation for the VirtualCube 1.0 was that the visitors always had to have internet access at all times, while the administrators had no administrator rights, and the visitors could not queue themselves onto an active queue. This is the Gantt chart made for the product management for this semester, which was broken down into 5 sprints, and each sprint is 2 weeks long. And we will be talking about the 2 main user stories that we worked on for this semester, this is the first user story, which is simulate add visitors to ride. What this user story does is, as an admin, I should have a control over on how many multiple visitors I add to a ride, and be able to compare the wait times for depending on how many people is on the ride, and also increase the wait times. And this is the use case made for that specific user story, which follows a simple step as as an admin, you should be logged in and also going to the Simulate Rides tab and be able to select a specific ride to add a number of how many random visitors you want to add. And this is the specific sequence diagram for that user story, which has the specific objects within the code as well, and follows the steps. And this is the use case diagram for the semester that with all the use cases that we have worked on, and also including the user stories from the VirtualCube 1.0 as well. And this is the second main user story that we worked on for this semester, which is the simulate DQ visitors per ride. And what this user story does is, as an admin, I should be able to remove manually a number of visitors from the queue, in order to move the queue along. So it's kind of a simulation. And this is the use case created for this user story, which follows the steps of you have to be logged in as an admin, and when you go to the admin rights table, you click on the DQ button, which DQs specific amount of how many visitors could go onto a ride times the concurrency of the ride. And this is the sequence diagram following those steps and the back end of the code, back end of the system as well. And for the architecture that we are using for the VirtualCube 2.0 is the 3-tier architecture and the multi-layer architecture, which allows us to have multiple users. It allows us to easily handle multiple traffics, because in a theme park there will be over hundreds of users trying to use the system at the same time. And for our system deployment, as a hardware, all you need is a computer and a smartphone as a client to use it. And for the software requirements, you will need to have a Windows 7 or higher OS system, and you could run it on a virtual machine or non-virtual machine, and also Tomcat version 8, a Sprint 4.0 framework, and a MySQL is required. And this is the persistent database management that we are using for VirtualCube 2.0, which contains the patron, visitors, the queue, the venue, which is the theme park itself, and the activities are the actual rides, so they don't have to be a ride, they could be a show as well. And for as the security and privacy, authenticated users or visitors could change password, update their profile, add and remove themselves from the queue, and check the ride status. And for the admins, they are allowed to change password, access other accounts, update their own profile, and add and remove visitors from rides and edit rides. And for non-visitors or admins, they could only create their accounts on the website. And this is the class diagram, minimal class diagram for the Simulate Add Visitor rides, which contains all the objects used in the sequence diagram. This is a simple state machine. All the state machine does is you start out by adding a visitor to a ride, which is within the list of ride states, then it finishes. And this is a simple algorithm for the Simulate Add Visitors to Ride user story, which is you pick a ride, then you want whatever number of visitors you want to add to a ride, and if you finish adding, yes. If not, then you keep on adding that visitor to that specific ride, then you end it. This is one of the test cases, sunny day test cases for the Simulate Add Visitors to Rides, which the purpose is to successfully add records to queue for a specific ride, which let's say we want to add 10 random records, and it comes out as how many records there were plus 10. And for a rainy day record, let's say you want to successfully add correct numbers of records to a specific ride, and let's say you add apples in the text field to add a number of add random records, but instead it's an apple, so it's not a number, so it'll give us the error message saying that the value entered in the add random records is not a valid request. Well, this is the test script created from the IBM rational testing function, which follows the simple steps in the use case. And this is the class diagram for the Simulate DQ Visitors to Ride, which uses all the methods and the objects from the sequence diagram. And this is also the simple state machine, which you create the instance of the DQ, and if let's say a visitor is on the line, and when you DQ, the visitor moves forward in the line, and if they're not on the front of the line, then they go back onto the line. But if you are in front of the line, you get onto the ride, which you are removed from the line, and that finishes it. This is a simple algorithm for that was used in the code. You look at how many people could go on the ride and just remove that certain amount of people, and that's all there is to it. And this is the test case, sunny day test case for the Simulate DQ Visitor, which is it allows users to remove themselves from the queue, displaying update user my accounts. And when you click on DQ, it will remove that certain amount of records from that ride, which will give us a actual real response. And this is the rainy day Simulate DQ for rides, which is when they try to remove themselves off in my account, but the ride is actually not included in my accounts, so it gives an error. And this is the test script made for the Simulate DQ for ride, which follows the simple steps from the use case. To go over the demo very quickly, we talked about the two user stories previously, which is the admin simulates add records and DQ rides, which I'll first show the admins when they add records to a ride. So let's go to Splash Mountains in the Simulate Rides window, and there's currently 18 records to it. So let's say I want to add 2 more records. Random records, so I click on submits, and if I refresh, it will increase the 18 to 20, and also the wait time will increase according to how many records I have added. And for the second user story, which is a DQ, if I click on the DQ button, and if I click on refresh, it DQs 8 records, which is because there's 8 people in the max capacity, so it goes down to 12, and the wait time also decreases. And it also shows us that you have successfully DQ'd the ride as well. And that's it for the demo. Thank you for listening to the intro video, and I hope you have a good time working on this system. Thank you.